Okay, so in this video we will be discussing the questions of relation and function. So our first question is, let f and g be two real valued functions. F and g be two real valued function defined by fx is equals to x plus 1 and gx is equals to 2x minus 3. So these are the function like fx is equals x plus 1 and gx is equals 2x minus 3. These are the two functions. Now find f plus g, f minus g and f by g. So as we have already discussed this in theory part, now f plus g, starting with the 1, the first part, f plus g of x, this will be fx plus gx. So this will be fx plus gx. Now what is fx? Fx is x plus 1. Fx is x plus 1 plus gx is 2x minus 3. Open the bracket, x plus 1 plus 2x minus 3. So this will be 3x, x plus 2x, 3x, 1 minus 3 is basically minus 2. So 3x minus 2, that's our answer. Now the second part is f minus g. So f minus g of x is fx minus gx. Now we know fx is x plus 1, so x plus 1 minus gx is 2x minus 3. So 2x minus 3. Now open the bracket. So this is x plus 1 minus 2x plus 3. Minus will become plus. So x minus 2x is minus x. 1 plus 3 is 4. So basically the answer is minus x plus 4. You can write this as x minus 4. Okay. Now the third part. Third part is f by g. F by g of x, that is equals to fx by gx. Now again, what was fx? Fx is x plus 1. So this is plus 1. Gx is 2x minus 3 upon 2x minus 3. Now this is the answer of 2x minus 3. Okay. So our next example is, find the domain and the range of real function fx is equals to 1 upon x minus 3. As we have already discussed domain and range in our theory part. Now what is given to us is fx is 1 upon x minus 3. Now you see clearly fx is not defined when this part becomes 0 or when x minus 3 becomes 0. So this thing is not defined. Why? Because 1 by 0 is not defined, isn't it ready? That's fine. X minus 3 equal to 0. That is when x is equals to 3. So basically this is not defined only when x equal to 3. Rest we put any real numbers, that will be defined. So we write domain of f, that is equals to r minus 3. So this is the domain of f. Now we clearly know that domain is basically the values of what values of x we can substitute over here so that the function is defined. Range is the values of y. Now y is 1 upon x minus 3. So solving it further, this will cross multiplying, x minus 3 equals 1 by y, cross multiply. Now what is x? This implies x is 1 upon y plus 3, which again implies x is equals to, solving this we get 1 plus 3y by y. Now again, this is a rational function. Now this rational function is again not defined when y becomes 0. So the x is not defined when y equals to 0. So x is not defined when y equals 0. So what is the range? So basically range is what? The values of y. So y cannot take the value 0, rest any real numbers value. So range of f is equals to r minus 0. So domain of f is r minus 3, range of f is r minus 0. Okay, our next example. So our next example is, find the domain and the range of real function fx is equals to under root of x minus 1. Now this is under root of x minus 1. Now fx is what? Under root of x minus 1. We have to find both domain and range. Clearly fx is not defined when x minus 1 is less than 0. Why? When x minus 1 less than 0, why? Because we cannot have negative values of under root. Okay, when x is less than 1. That means it is not defined when x minus 1 is less than 0 or when x is less than 1. So basically it's not defined when x is less than 1. So fx is defined, fx is defined when it is defined. So fx is defined only when x is greater than equals to 1. So what will be the domain? Domain means 1 and then so on, means the any number. So basically we can write this as domain of f is this thing, 1 is included to infinite, but we cannot include infinity. So this is our domain, like greater than 1. Now to find the range. Now the range of, again, now see, this was the function fx equal to under root of x minus 1, fx is y, so we can take fx as y. So this will be y equals under root of x minus 1. Okay, now squaring both sides, we get y square equals x minus 1, or you can write this as y square plus 1 equals x. So see, for every real value of y, whatever you put the value of y, the x is defined. That means the x is real. So range of f is all real number. So hence domain of f is 1 comma infinity and range of f is r. So again, one point that I want to mention again is that in case of domain we find the values of x, and in y we check, and in range we check the values of y. Okay, moving on to the next example. Yeah, here's the next example. Find the domain and the range of the real function fx is equals to under root of 9 minus x square. Find the domain and range of real function fx equal to under root of 9 minus x square. Okay, so here is our function. Fx is under root of 9 minus x square. Okay, now again this is an under root. So if 9 minus x square is less than 0, that is not defined. So we directly take the values in which it is defined. Okay, so it is defined only. So it is not defined when 9 minus x square is less than 0. So we take is defined only when 9 minus x square is greater than equals to 0. So this is when it is defined at 9 minus x square greater than equals to 0. So we can write this as, now when we, you know that when in case of inequality, when we change the sign, the inequality will also change. So if we write this as x square minus 9, this inequality will become is less than equal to 0. This implies x square is less than equals to 9. Equals to 9. So which implies x is, now this implies x is either less than equals to 3 or x is greater than equals to minus 3, which is basically minus 3 is less than equals to x is less than equals to 3. That means x lies between minus 3 to 3. We can put minus 3. So minus 3, that will give you 9, which is less than equal to 9. 3 again 9, which is less than equal to 9. Now if you take 4, okay, so basically x lies between minus 3 to 3. Now suppose we take out of this, suppose 4, so this becomes 16, which is not less than equals to 9. Again, if it is minus 4, this will again become 16, which is not less than equals to 9. So x lies between minus 3 to 3. So this is what the domain of f. The domain of f equals minus 3 to 3. This is the domain of f. Now for each, now for the range. Now for each x belongs to, now suppose for each x belongs to minus 3 comma 3. Now actually we are getting what is y. Now take this value, sorry, take this value, fx is 9 minus, or just put a line over here and we write y equals under root of 9 minus x square. So if we substitute the values between minus 3 to 3 over here, what is y? Y will have the value in the interval 0, 3 only. So y will have values only in the interval 0, 3. If you substitute the value of x from minus 3 to 3 over this, the range of f is this 0, 3. 0, 3. Hence, the domain of f is minus 3, 3. The range of f is 0, 3. Our next example, find the domain and the range of real function fx equals to 1 minus x square. So here is the point, fx equals to 1 upon 1 minus x square. Now we have fx equals 1 upon 1 minus x square. Clearly fx is not defined. Now simple, it is 1 upon 1 minus x square. So it is not defined when x, this part becomes 0. So clearly is not defined when 1 minus x square becomes 0. And 1 minus x square becomes 0, that is when x is equals plus minus 1. So it is not defined. And while the other next number, that is defined. So domain of f equals r minus 1 comma 1. So this is the domain of f. So domain of f equals r minus 1 means leaving minus 1 and 1, rest all we can put numbers. Now for the range. Also, what is y? Y is actually, now see, fx is 1 minus x square, which is y only. Basically y is 1 upon 1 minus x square. Okay, So this implies cross multiplication 1 minus x square equals 1 upon y. So which in turn implies now x square, taking x square to that side, so x square will be 1 plus 1 by y. This implies x is plus minus under root of 1. Oh, I'm sorry. This should be minus 1 minus 1 by y. So x is equal to plus minus 1 minus 1 by y. Now see, again this is an under root. So this is not defined when 1 minus 1 by y is less than 0. Now by cross multiplying and doing the calculation, this implies 1 is less than 1 by y, or basically y is less than 1. So which is actually not defined when y is less than 1. So it's defined when y is greater than equals to 1. In this case, not defined, but defined when y is greater than equals to 1. The range of f that equals 1 comma infinity. This is what the range of f. 1 comma infinity greater than 1. So domain of f is 1 minus r minus minus 1 1. Range of f is 1 comma infinity. The relation, now the next question. The relation is defined by fx equals to x square when x lies between 0 to 3, and 3x when x lies between 3 to 10. Now the relation g is defined by gx is x square. This lies between 0 to 2, and 3x when it lies between 2 to 10. Now we have to show that f is a function and g is not a function. Now what's given to us is that fx is x square for x lies between 0 to 3, and 3x for x lies between 3 to 10. Okay, so what we can write is that like fx equals x square. Now this is well defined. This is well defined in what? In 0 less than equals to x less than equals to 3. That's what is given to us. Similarly, fx equals 3x. This is also well defined in 3 less than equals to x less than equals 10. Okay. Now we will take at x equals to 3. At x equals 3. Now at x equals to 3, we can take this one as well as this one. So at x equals to 3, fx equals x square. This implies f3. Now what is 3 square? 9. Now this implies f3 equals 9. Okay. Now again at x equals to 3, fx x equal to 3, fx is equals 3x. We are taking this. So what is f3? f3 is again 9. So see, if you see, fx is defined at x equals 3. f3 is 9. f3 is 9. Hence f is a function. So fx, this is defined at x equals 3. Hence f is a function. What do you mean by defined? That means it has a unique image, which is 9. Now the b part, let's take the gx. Gx was, see the question again. Now gx was equals x square when it lies between 0 to 2, and equals 3x when it lies between 2 to 10. So let's again write it over here. So gx is equals to x square is again well defined in 0 less than equals x less than equals 2. So this is well defined. Okay, now again we take gx is equals to 3x is again well defined in 2 less than equals to x less than equals to 10. Now at x equals 2, gx equals x square. Now gx x square, this implies g2 is equals to 4. Now again at x equals to 2, gx equals 3x. This implies g2 equals 3 into 2, which is 6. Now see, that's what is here, that 2 has an image 4, 2 has an image 6. So it doesn't have a unique image, it has two images. Hence gx is not a function. Not a function. Why f was function? Because it has a unique image, which was 9 at 3. This is not a function because at 2 this has 4 and 6. So our next question is, find the domain of the function fx is x square plus 2x plus 1 upon x square minus 8x plus 12. So here you should see, we just have to find the domain of this thing. Fx is x square plus 2x plus 1. So clearly this is a rational function. So this function is to be defined. So this function is to be defined only when this part is not equal to 0. Because if this is 0, this function is not defined, as we have done in the rational diagram. Rational functions. So this thing, x square minus 8x plus 12 should not be equal to 0. Okay, now do the midterm splitting. So this is 12 minus 8, we can take minus 6 and minus 2. So this is x square minus 6x minus 2x plus 12 should not be equal to 0. Next step, take x common, x minus 6 minus 2 common, x minus 6 should not be equal to 0. X minus 6, x minus 2 should not be equal to 0, which implies x should not be equal to 6 and x should not be equal to 2. So what is the domain of this thing? So domain will be that will be r minus these two numbers 2, 6. So this is the domain. Okay, next example. Now here's the question. Fx is equal to x upon x square upon 1 plus x square. X belongs to real number. To be a function from R to R, determine the range of f. In this case, we have to just find the range of f. Now see, the function f is x comma x square upon 1 plus x square. Basically, this is an ordered pair in which this represents x and this one is y. So since we have to find range, we directly take what's given to us. Y equals x square upon 1 plus x square. Now see, this is y, or you can write this as fx also. This is fx, or fx is the same thing. Now see, fx or y is positive for all values of x. See, whatever you keep the values of x, whether it's negative or positive, ultimately it's a square that will become positive. Okay. Also, this is a point to be noted, like 1 plus x square is always greater than x square. That means this fraction is always less than 1. But it can be 0, because if we put x 0 and this as 0, that will be 0 by 1, which is 0, which can be 0, but this is less than 1. Okay, so basically y has the value which lies between 0 and 1, which can be 0, but this is less than 1, because this is a fraction which is always less than 1 because of this thing. So hence, range. How to write in the range? So range of y, the range of f that is 0, 1. This is the range of this function. Okay, our next example. Now this is given to you. Fx is 1, 1, 2, 3, 0, -1, -1, -3. This is a function. Let a be a function from z to z defined by. Now this is defined by fx is ax plus b. Look at this point, ax plus b. For some integers a and b, determine a and b. So find a and b. So see, we have been given the function. That means if this is x, this is y, this is x, this is y. Now if we write the function like fx equals ax plus b. So basically we have two variables a and b which we have to find. Okay, so now substitute the value from this, like from this point first. 1, 1. So x is 1, y is 1. You can write this as y only. So taking this, so 1 equals a plus b. Why? Because this is 1. So we have equation number 1. 1 is a plus b. Now again, now take this one, 2, 3. That means y is 2 and x is 2 and y is 3. So x is 2 and y is 3. Again at this function. So 3 equals 2a plus b. This is equation 2. Now solving these two equations simultaneously. Okay, we can solve for a and b. So basically you take these two equations, you minus them, b will get cancelled. This will be 1 minus 3 is minus 2. Minus 2, a minus 2a is minus a, b cancel. So what is a? Minus 2 equals minus a equals 2. Now substituting a equals to 2 in this, b is minus 1. So 1 equals 2 plus b. So this implies b is minus 1. So this equation fx is now, what was fx? Is ax plus b. What is a? 2b is minus 1. So this is 2x minus 1. So fx is 2x minus 1. Okay, moving on to our next example. Next question. Now, let R be a relation from natural number to natural number defined by, now this is R. Is a comma b says that a comma b belongs to natural number and a equals to b square. Now you have to prove that are the following true, and you have to write the statement also or justify them. Like a comma a belongs to R for all a belongs to natural number. Now see, given that this is what? R is a relation from n to n. Okay, now which is defined by this thing. Like R is a comma b belongs to natural number and a equals to b square. Okay, taking the first point. A comma a belongs to R. A comma a belongs to R for all a belongs to natural number. Now this is false. Why? Because a equals to a square is true only for a equals to 1. Like 1 is equals to 1 square. That's fine. But 2 is not equals to 2 square. 3 is not equal to 3 square and so on. So only for 1 and not for all natural number, given that a belongs to natural number. Hence, this is not a relation. Not a relation. Point number 2. Now, this is the point number 2. A comma b belongs to real number. B comma a belongs to R. So like, write it. Okay. a comma b belongs to real implies that b comma a belongs to real. Now see, this is again false, because if a equals to b square, then b equals to a square is not true. Not true. Why? Let's take an example. For just consider 2. Like 4 is equals to 2 square. Okay. But 2 is not equals to 4 square. So hence this is again not a relation. Third point. A belongs to R, B belongs to R. This implies C belongs to the relation. Now see, again, let's write it. A comma B belongs to real number. No, sorry, the relation. R stands for the relation. B comma C belongs to relation. This implies A comma C belongs to relation. Now we have to prove it. Now this is again false, because if A is equals to B square, okay, and related B equals to C square, they are related. But if you see, if A equals to B square and B equal to C square, so what A will become? A will become C square whole square, which is C to the power 4, which is not equals to C square. Hence, this is also not a relation. Let f be a subset of z comma c cross z defined by f that is equals to ab comma a plus b. So this is comma a plus b. A comma b belongs to integer. Now you have to prove that. Now just prove that is a function from I think I have written something wrong. Is a function from z to z. Oh, this is actually a question. So is a function from z to z. So this is a function from z to z. You have to prove that. Now just take. Now see, a comma b, ab comma a plus b. These are what? This is what? X and this is y. A comma b belongs to integer. That is ab comma a plus b. Now we just take simple numbers. Like suppose we take a equals to 0, and b equals 1. And b equals 1. Okay. So what is AB? AB is, sorry, it's not a comma. AB will be 0 into 1, which is 0. What is A plus B? Means the y part is 0 plus 1, which is equals 1. So basically this will become 0 comma 1. Okay. Because x, which is AB, is 0, and a plus b, which is 0 plus 1, is 1, which is y. Okay. Now, suppose if we take again a equals to 0, but b equals to 2. What is AB? 0 into 2, which is 0. And what is a plus b? Is 0 plus 2, which is equals to 2. So this becomes 0 comma 2. Now see again, what we are seeing over here, that 0 has two images, 1 and 2. It doesn't have a unique image. It has two images, 1 and 2. So 0 comma 1, 0 comma 2. So thence this is not a function. Or as you know from the previous previous video we have discussed, if they have same first coordinate, it's not a function. Moving on to the next question. Now, here A is 9, 10, 11, 12, 13. So this is set A, 9, 10, 11, 12, 13. Let f is a function from A to n. Function from A to n defined by fn equals to the highest prime factor of n. Find the range of the function. Now find the range of the function f. Now A is 9, 10, 11, 12, 13. Now what is given that? 9, 10, 11, 12, 13. F is a function from A to N. This is given to you. Okay. Now we will find the highest prime factors of all the elements of the given set by factorizing them into a prime factor. So starting with n equals to 9. So if you the prime factors of 9 are 1 into 3 into 3. So if we take the highest prime factor, that will be 3. Okay. For n equals to 10, this is 10 equals 1 into 2 into 5. So highest prime factor that will be 5 of 10. For n equals 11 is just, I think, 1 into 11. Yeah, it's 1 into 11. So highest prime factor equals 11. For n equals 12, this is 1 into 2 into 2 into 3. So highest prime factor is what? 3. Now for n equals to 13, which is basically, I think, because it's a prime number by I, it's 1 into 13. So highest prime factor is 13 only. Okay. So now f, if we define f, now function will be f is C. This will be. For 9, it was 3. For 10, it was 5. For 11, 11. For 12, it was 3. For 13, it was 13. 13, 13. Okay. Now this is a function. Just repeat it. Now this is a function because there are no two elements. The first coordinate is repeated and they all have the unique images. So range of f, that will be 3, 5, 11, 13. So this is the range. Okay.